last time we found out that the derivative of the function f of x equals e to the power x is just e to the power x. So a function which is its own derivative. Let's use the chain rule to go a little bit farther and find derivatives for all of the exponential functions regardless of their base. So if I have the expression b to the power x, I want to calculate its derivative. The way that I'm going to do that takes advantage both of rules for exponents and takes advantage of rules of derivatives. So let me say that b is some positive number. I need b to be a positive number to define the base of an exponential. Then I can rewrite b as e to the power the natural logarithm of b, right? The natural logarithm is just the number, so that e to that power makes b. And then I can rewrite b to the power x by saying that this is e raised to the power natural log of b, and then raised again to the power x. Well, my rules for exponents say that that's the same as taking e to the power the natural log of b times x. So now I'm all set to use my chain rule. If I'm going to take the derivative d on dx of the exponential function b to the x power, that's the same as d on dx applied to e to the power natural log of b times x. So we're going to say that the outside function here is the natural exponential function, e to the power x, which is its own derivative. And the inside function is just going to be x times a constant, natural log of b. So my derivative here is going to be e to the power natural log of b times x times the derivative of constant times x. Well, the derivative of constant times x is just that constant. So e raised to the power natural log of bx is my function. And then the derivative of that function is e to the power natural log of b times x, all times another natural log of b. So let's go ahead and write that as b to the power x times the natural log of b. Now this is my derivative rule for any exponential function. The d on dx of b to the power x is b to the power x times the log of b, the natural log, that is. So this will be true so long as b is any positive constant. Let's go ahead and use this in practice. So for b equals 2, the derivative d on dx of 2 to the power x will be 2 to the power x times the natural log of 2. Now, we saw this derivative in our last lecture. We were trying to evaluate it numerically. And we said, well, we've got some limit here that seems to be approaching 0.69. What is that? And at the time, we said we don't know. But now, thanks to the chain rule, there's only one number that could be. It's the natural log of 2. And the natural log of 2 does start out with its decimal expansion 0.693147 and so on. So this decimal right here is the value of that limit that we saw in our previous lecture.